According to the World Health Organization (WHO), around 37.3 million people suffer injuries each year, requiring medical treatment due to tripping and falling. These accidents are especially common among the elders, often occur at night when poor visibility makes it difficult to see obstacles or uneven surfaces. One strategy for seniors is to carry flashlight when moving around, such as walking to the nearby areas, but this solution is often inconvenient and inconsistent in ensuring safety. Flashlight can be misplaced, require manual handling, and may not be accessible when needed, all of which reduce their effectiveness. Additionally, relying on separate flashlight devices can be impractical for elderly. For example, handheld flashlight used during nighttime ambulation requires continuous manual operation, which can impede postural stability by occupying one hand, thereby reducing ease and safety of the movement and increasing the risk of imbalance. Furthermore, inconsistent beam direction caused by natural arm movement diminish the effectiveness of illumination in identifying floor-level hazards. To solve this problem, we are developing a household shoe integrated with LED flashlight, a practical wearable solution designed to enhance visibility at night and prevent tripping accidents. Since shoes are worn at home, embedding lighting directly to the footwear ensure that illumination is always available at floor level where hazards are most likely to be. This approach aims to improve safety, independence, and confidence for elderly individuals in their everyday environment. Moving on to objective. The objective of this project is to design and construct a simple electrical circuit integrated into shoes, applying physics concepts such as current flow and circuit design. The goal is to create a practical solution that improves nighttime mobility for the elderly by providing built-in LED lighting, helping them to navigate dark or low-light areas more safely and independently. These specialized LightPath shoes are designed to illuminate only when needed. The circuit incorporates both resistor and pressure-activated buttons located at the base of the shoe. The resistor helps regulate leakage current, while the pressure switch ensures that the circuit is only completed when wearer takes a step. This means the LED lights up only during movement, making the system energy sufficient, safe, and practical. Illumination is provided exactly at floor level, where visibility is most needed to help prevent trips and falls. To ensure user safety, the circuit is protected by an insulating layer that covers the base of the shoe. This barrier helps prevent leakage current and reduces the risk of electrical shock, making the design safer for daily use. Materials are listed separately in 3 major categories on the screen.
To successfully complete this large-scale project, we divided our responsibilities according to each member's strengths and skills. Fu served as the team's lead electrical engineer in charge of connecting the circuits and ensuring the light responded correctly to walking movements. Tanya focused on researching background information for our documentation and also handled technical tasks like soldering to ensure the circuit's connections were secure and stable. Mena took the role of designer, planning the layout and structure to ensure the showpiece functioned accordingly to our initial vision. Lastly, Mari contributed across various roles, conducting background research, preparing material, supporting theoretical aspects of the project, and documenting our progress through videos recording.
Method, physics theories, and law. For this project to work out efficiently and safely, we will need to utilize multiple physics theories and, most importantly, the Ohm's law, to keep us safe during the process and prevent damage to our components. In order to have all 3 LEDs light up, we connected them in a series circuit with these components: a 9V Panasonic alkaline battery, a momentary push-button switch, and a 220 ohms resistor. A LED bulb requires around 2.8 to 3 volts, which means that 3 of them would be around 8.4 to 9 volts. So if we are using a 9V alkaline battery, a resistor is pretty much needed to prevent overcurrent. According to Ohm's law, V is equal to IR, and I is equal to V over R. Voltage is equal to current times resistance, and current is equal to voltage divided by resistance. This means that resistance is inversely proportional to current, and this would mean that adding a resistor will lower the current, preventing the LED bulbs from burning out and staying within safe limits. This circuit demonstrates the conservation of energy theory, which states energy is neither created nor destroyed, only transferred. The electrical energy from a battery is transferred across the circuit, with each LED receiving a portion of the total voltage. Since the circuit is a series circuit, the 9V from the battery will be distributed across the circuit. The voltage drops across the 3 LEDs, powering off them equally. This also means that voltage is divided among the components in the circuit, and if one component in a series circuit fails or is disconnected, the entire circuit becomes open and stops functioning entirely.
After finalizing our concept, we move forward with researching the appropriate types of circuits and materials to bring our idea to life. We ordered several components, such as different types of switches, to test their compatibility in our design. Some switches turned out to be too large or tall, so we had to experiment with building circuits around them to determine whether the lights could activate effectively with each step. User comfort was also a key factor in our design, especially since the target users are elderly individuals. Initially, we planned to use wood as the base of the shoe insert, but later we switched to hard fill material to enhance comfort while maintaining structural integrity. We tested multiple types of LED to ensure the lights would be bright enough to provide visibility in the dark. Once we finalized the list of materials and completed our design plan, we carefully cut the foam base to the mesh shoe shapes and began to assembling the circuit. This included soldering components together and repeatedly testing the functionality to ensure that the lights reliably turn on with each step. After confirming that our base was properly insulated, we integrated into the actual shoe. Finally, we conducted our own trial test before having an elderly family member wear it and test the product in a real nighttime scenario. Throughout the process, our design underwent several revisions. However, through teamwork, persistence, and combining our individual skills, we were able to create a product that matched our expectations and could make a real impact.
Our final product works like any other shoe, providing comfort and a platform to step on while taking walks. Each shoe lights up as the leg is taking a step, providing sufficient light to be visible during the night. What could be improved is the safety of the shoe, as each battery could fall out if the tape runs out of its strength. In addition, if the battery were to run out of power, it would take a good amount of work to replace the battery. However, with our product, if one LED light were to have any complications, the other LEDs on the same shoe would not light up and the compartments would have to be taken apart to fix. With this, people would rather throw the whole shoe away than fixing any soldiers or compartments themselves. During the process of the project, we were able to acquire soldering skills like how to connect circuits together or finding pieces that will create a connection that actually allows light to pass through and reach the light bulb. As a group, we initially had to solder and desolder our circuits many times to alter our materials and find many ways to create a circuit path for the light to reach the bulb. As the project progressed, it didn't take long for us to make our final connections and put together the shoe. Outside school-related lessons, we acquired skills to problem solve and work together as a team to work over any obstacles we faced. Although the lighting up the shoe could be improved in many ways, the final product meets its purpose to provide lighting for the user during a dark night. Thank you.